Hello students, welcome back to my next lecture on basic maths. So in your previous lecture we are dealing with permutations and combination, that is chapter 2. So today in this session we shall continue with the same chapter. So let's get started. So in your previous lecture we have dealt with many types of permutations. So with that types we will use some examples. So based on the last type, so our example will be first one, find the number of permutations of the letters of the word engineering. How many of these? A, begin with E and end with E. Second one, B, have all the three E's together. C, begin with GIN and end with GRIN. D, all the vowels are not together. E, no two vowels are together. So students, here with the same word, that is engineering, we have to solve these 5 sub questions. So before that, find the number of letters in the word engineering. So the word engineering has 11 letters, out of which E is repeated 3 times. Count it students now. N is repeated 3 times and G is repeated 2 times. I is repeated 2 times. Therefore, out of total number, that is 11, E is equals to 3, N is equals to 3, G is 2, I is 2. Means these number of times they are repeated. So, from this we can write the total permutations, that is n factorial upon x factorial, y factorial, z factorial, w factorial. So, the number of repeated terms will come in the denominator, that is 11 factorial upon 3 factorial, 3 factorial, 2 factorial into 2 factorials. So, this is the main answer from the word engineering. Now, let us see the first one from this same word, begin with E and end with E. So, here write down the word engineering. So, circle E and E. So, these two numbers are end positions, beginning as well as end with E only. So, remaining letters permutations will be, out of 11, remove these two letters E and E. So, it will be 9 factorial. Then, among this, the number of repeated letters have to be grouped. So, N is 3 times repeated, G is 2 times repeated, I is 2 times repeated. So, write them in the denominator. Now, second question, all 3 E's are together. So, number of E's in this word are 3. So, if consider them as a 1 unit, and remaining, how many letters will remain now? In 11, these 3 will become one group and the remaining letters will be, count them, NGI, NRING. So, that will be 8 letters. So, this is E will become 1 unit plus 8 will be 9 and number of terms, letters will be repeated, will be written in the denominator. I hope you are understanding this. Next, the 3 is considered as 1 can be arranged in only one way, as all the 3 letters are the same. Therefore, the total permutations is 9 factorial upon 3 factorial into 2 factorial into 2 factorial. Next, begin with GIN and end with GRIN. So now write down these 3 letters in the beginning and last 4 letters at the last. So how many letters will remain now? See, total here 3 letters in the beginning, 4 letters at the end. So in 11, subtract these 7 letters, you will get 4 letters. So that will come in the numerator. In that, E is repeated 3 times. So that will come in the denominator. That is 4 factorial upon 3 factorial. Next one, all the vowels are not together. So all the vowels are not together is written as total arrangement minus all vowels are together. So to get the negative answer, you write down the positive answer first, then in total you have to subtract this vowels which are together. Automatically you will get all vowels which are not together. So if you do so, you get the total arrangement. That is total arrangement we have done in the beginning only. That is 11 factorial upon 3 factorial, 3 factorial, 2 factorial and 2 factorial. This is a main question answer, that is total arrangement of the word engineering. In that, how many vowels you are having? There are 5 vowels in this word. All vowels are together can be done like the word engineering has 5 vowels which can be considered as one unit, and the remaining letters of the permutations are, see, the all together all letters which are vowels make it one unit, and remaining 6 letters will be equals to 7. So total will be here 7. In that, N is repeated 3 times among the remaining letters. Then G is repeated 2 times. Therefore, number of permutations here will be 7 factorial in the numerator, and denominator will be the repeated terms, that is repeated letters, 3 factorial into 2 factorial. For each of these, the vowels taken as one unit can be again arranged as 5 factorial upon, in that E is repeated 3 times, I is repeated 2 times, can be written as 5 factorial upon 3 factorial into 2 factorial. Hence, total words with vowels together is 7 factorial divided by 3 factorial into 2 factorial into 5 factorial upon 3 factorial into 2 factorial. Therefore, now subtract these two, that is total arrangement minus the vowels which are together. So that will be your main answer, that is total words with all vowels not together is written as total arrangement minus total words with vowels together is your final answer. Next question. No two vowels are together. First arrange the 6 consonants, that is N, G, N, R and G. So total letters in this word are 6. In that, N is repeated 3 times, G is repeated 2 times. So this can be done in 6 factorial divided by 3 factorial into 2 factorial ways. If there are 6 letters, then there are 7 gaps. Yes or no? In between all 6 letters, 6 gaps will be there, and in the beginning position there will be one more gap. So altogether there are 7 gaps. In the 7 gaps, we have to arrange the 5 vowels. But in these 5 vowels, E is repeated 3 times and I is repeated twice. Therefore, total ways is out of 7 P3 3 ways we have divided by 3 factorial into 2 factorial. Therefore, total words with no two vowels are together is equals to 6 factorial divided by 3 factorial into 2 factorial into 7p3 divided by 3 factorial into 2 factorial. The next concept in the same lesson, that is permutation and combination, is circular permutation. So when objects are arranged along a closed curve like a circle or a ring, the permutations are known as circular permutation. It is important to note that in a circular arrangement there is neither a beginning nor an end. For example, if we have to arrange 4 letters A, B, C and D, in case of a linear permutation in the sense row wise or column wise. So we can arrange the letters like A, B, C, D or B, C, D, A or C, D, A, B or D, A, B, C. These are different arrangements. But in case of circular arrangements, they are all same only. So every 4 arrangements are considered as 1. Hence, if linear permutations are 4 factorial, then circular permutations are 4 factorial upon 4, which is equals to 3 factorial only. Hence, in general, n objects can be arranged in a circle in n factorial upon n, that is equals to n minus 1 factorial. Hence, the number of circular permutations of n objects is n minus 1 factorial. Another explanation is, as the number of circular permutations depends on the relative position of the objects, we fix the position of one object and then arrange the remaining as n minus 1 objects in all possible ways. This can be done in n minus 1 ways. Note here that students, if the clockwise and anti-clockwise orders are not distinguishable, then the number of circular permutations is n minus 1 upon 2. n minus 1 factorial in the numerator divided by 2. Only when, if in the question if they ask clockwise and anti-clockwise orders which are not distinguishable, then you can use this formula, that is n minus 1 factorial upon 2. Example on this: in how many ways can 8 persons be seated at a round table? So here see, in a round table there are 8 people have to be seated. So this is a circular permutation. Since there is a round table, so arrangement will be circular motion only. Hence, number of ways 8 persons can be seated in a round table is written as 8 minus 1, that is 7 factorial. Okay, now here in next question, in how many ways can 10 different precious stones be set to form necklace? So here see students, n value is 10 and n different precious stones we have. So in case of necklace, there is no distinction between the clockwise and anti-clockwise arrangement. Therefore, second formula is used. Hence, the number of ways is equals to n minus 1 factorial, that is 10 minus 1 equal to 9 factorial divided by 2. So till here students, I will conclude. In your next session, I will start with combinations with some important worked examples and exercise questions for exam purpose. Thank you.